All right, welcome to this podcast. We're going to talk about graphing a function with a restricted domain on a TI-84 or a TI-83. So if you don't have your graphing calculator in front of you right now, stop this podcast, go get it, make sure it's got working batteries in it. Should look like this, although it might not be pink. And make sure you follow along with me and enter everything in your calculator that I enter in my calculator. Okay, so everybody has a calculator now. So here's our function. This is a function g of x is equal to negative x squared plus 4x plus 12. That is a quadratic equation. We know the graph's going to look like a parabola, but instead of the domain being all real numbers, for some reason it's been restricted to the interval from -3 to 8. That's all we want x to do. Now, if you put that on your calculator, uh, it's just going to graph everything for whatever window you have. If your window goes from -10 to 10, it's going to go from -10 to 10. But we're going to figure out a way to trick our calculators into graphing just that interval from -3 to 8. The way we're going to do that is we're going to use something called a Boolean variable. A Boolean variable is a variable that the variable can either take on the value 1 if it's a true statement, or 0 if it's a false statement. So for example, if I said that 5 is greater than 0, that's a true statement, so that would produce the output 1. If I say 5 is less than -3, that is a false statement, so it's going to produce the output 0. Let me show you what that looks like on your calculator, just on the home screen. So let's put in 5. Now here's where you're going to find these inequality symbols on your calculator. You've probably never used these before. 5, you press second, math, and in there, number 3 is going to be the greater than symbol. 5 is greater than 0. True statement, produce the number 1. 5, back to second, test, is less than, that's 5, is less than -3. That's a false statement, that presses 0. And by the way, if you can't remember where anything is in a menu, like if you can't remember where those less than or equal to symbols are hiding, you can always press second catalog, and you, in this case, we'd want to scroll up, and all the symbols, or if when you scroll up, if you scroll down, you have to scroll through the whole alphabet. Now you still have to scroll through a bunch of junk, but then here they are. And there's lots of things in here. So whenever you forget where any symbol or command is, by the way, if you press the letter A, you'll get to the A of the alphabet. If you press level B, you'll get to the B in the alphabet. So you can kind of quickly go through the alphabet that way. Anyhow, back to the task at hand, we are going to we're going to trick our calculator using those Boolean variables into graphing what we want. So here's how we're going to do it. Put in -x squared plus 4x plus 12 into the y equals menu. Now, we know that if you divide by 0, you get an undefined result. So if anything undefined, your calculator won't graph it. It won't graph the square root of a negative number or something divided by 0. So if we can, here's what we're going to do. We're going to divide by this inequality statement that we have that is the domain. So we're going to say -3. Let's find that inequality under the math symbol is less than or equal to x. You can't write it like the way it's written on the page. You can't write x between -3 and 8. You have to use the word and that's also in the test menu, but it's under logic. logical operators like we used in geometry last year when we did truth tables. And x is, second math, less than or equal to 8. Close parentheses. So here's how this is going to work. Let's say the calculator is calculating values to graph here, and it sees the number -4. Well, -4 makes that inequality parentheses false, so it's going to produce a 0. So it's going to 12 divided by 0, which is undefined, so it's not going to graph anything. But when it gets to -3, it's going to see that, hey, -3 is less than or equal to -3. That's a true statement. And -3 is less than or equal to less than or equal to 8. Hey, that's a true statement. It's an and statement. They both have to be true to make it true. That produces a 1. 12 divided by 1 is still 12. So it doesn't change the value of this function. It just tricks it into graphing it when we want it and not graphing it when we don't want it. Okay, so let's look at what the graph is. If we hit just zoom 6, kind of your standard screen, that's not a very good picture of this graph. So this is one of the trickier things about your graphing calculator, is kind of figuring out what window you want to use. Let's make a window that's bigger than the interval we're looking at. So let's make it go from -4 to 9. And then let's see what happens when we go. And it didn't. We're cutting off the top, and I don't think we were seeing the bottom that we wanted. So let's make it -20, and let's go up to +20. See if that does it for us. This is just kind of guesswork at this point from having looked at it already. Well, we're seeing the top, but I think we're not seeing all the bottom. So I'm going to make that go down to -30. See if that makes it. And I think I want to make my scale go by 5, so it looks a little nicer. We don't have that. There we go. Okay, so you see it's actually starting at -3 and stopping at 8. If I trace this, I can go over here. Watch what happens when we're seeing see the y values appearing on the screen as I see different x values, x and y values. When I get over here to the end, I get -2.6, -2.89. Hey, the next one, it skipped over, but now you can see the y equal is blank because it's undefined. Now, here's another little trick. Let me just show you this other thing. We might be interested in this case. What are the values at those endpoints? Easiest way to do that from a graph right now is to do second calc. This is going to be your favorite menu, by the way. What happens? Second calc value. What that does is if I put in -3, it'll give me the output for -3, which is exactly -9, it says. See, my calculator, the way it was set up, was skipping over the endpoint of -3 because of the way it works, the window is set up. And then if I just plug in 8, I don't have to do second calc again. I can just plug in 8, and it tells me -20. So I can actually see those endpoints. That might be something you're interested in if you're trying to find the range of values in this for this function. Okay, that's about it. Hope you get a lot out of that, and we can practice that in class.